Many students at one point or another will look at these equations and think to themselves, how do I apply this in real life? When most people think of what they want to do with any natural science as a career, almost all of them will say either become a teacher or go to graduate school. And while there's nothing wrong with either of those two options, people should not feel limited to just those two, as there is so much more that can be done. A great example of this is the nonprofit company Kickstart, founded by Martin Fisher. Kickstart has helped lift over 1 million people out of poverty, helped feed 12 million people each year, all using the simple physics you just learned. Let's try and see how. Kickstart was mainly focused on sub-Saharan Africa, where 80% of the population is farmers. And for those of you who don't know, much of Africa is a desert, which does not make it easy to get water for your farm. So let's ask ourselves a question. About how much water do you need for 1 acre of farmland? If we do just a little bit of Googling and make some general assumptions, we have 1 acre of land, 20,000 liters of water per acre, the water has to be moved about 10 meters from a well, and a person can work for about 2 hours on it and do some quick physics, we find out that it takes approximately 2 times 10 to the 6th joules of work to water 1 acre of farmland. But then you have to ask yourself, how are we possibly going to generate 200 kilojoules of power in sub-Saharan Africa? They don't exactly have nuclear reactors down there. So let's try and work the problem a little bit. As most of us know by now, there are many different forms of energy we can use to power things, but the easiest to obtain is kinetic energy. After all, we generate kinetic energy every time we move. From the example in the last video, we already know that a person can produce about 200 watts climbing a set of stairs. So let's apply that here. Since we know how much energy we need and how much we can produce, we can find out how long it will take to water our theoretical farm in Africa. And it turns out it would only take about 3 hours, or the length of one 8 a.m. class on a Monday.
Created using Powtoon.